So today's class also we will do a few more problems based on rotation mechanics. Next class we'll move on to gravitation. Okay, I'm sharing my screen. So till where did we do? So I remember doing this problem as the last one. That's what I have in my notes. So fourth one, yeah. Yeah, this is the last problem that we have done. Okay, we'll do one thing. We'll get started with the fifth one. We'll just do some warm up and then we'll go to the next topic. So we were doing problems based on pure rolling or rolling without slipping, right? So let's do the fifth one. So I've shared the question paper in WhatsApp. Those who don't have it, you can open it in it. If you're comfortable reading the question from here, you can read it. So now let's discuss. Tell me how to do this problem. So the question is saying that there is a string that is wound around a hollow cylinder. So what is the moment of inertia of a hollow cylinder about its axis? So all these things we need to note. So what is the moment of inertia of a hollow cylinder? Hollow cylinder behaves similar to a disc or a ring?
Ring.
Ring. So it is m r square,
R square.
right? Yeah. Of mass 5 kilogram and radius 0.5 meter. If the string is pulled with a horizontal force of 40 Newton and the cylinder is rolling without slipping, so it is under a pure rolling condition on a horizontal surface, then the angular acceleration of the cylinder will be, neglect the mass and thickness of the string. Okay. Now let's think logically. You have a cylinder. So I have certain questions, try to answer them. So you have a hollow cylinder and there is a force which is applied tangential to it, right? So due to the tangential pulling force of 40 Newton that is acting here, is the object going to revolve in the clockwise direction or anti-clockwise direction? Is it going to revolve in clockwise or anti-clockwise? So obviously it is going to be clockwise rotation, right? So the question is very simple. They're just asking us the angular acceleration. So wherever force is there and the force is acting at a certain distance from the axis of rotation, what is going to exist?
Torque.
There will be a torque, which is given by the value of force into perpendicular distance, right? Similarly, how is torque related to angular acceleration? Torque is equal to I alpha, right? So, or F into R will be equal to I into alpha. Is every information in our hand? So F into R is equal to M into R square into alpha. Can I write it like this? So R and R will get cancelled. So alpha will be equal to F divided by M into R. Force is how much? 40 Newton divided by mass is 5 into radius is 0.5. That is half. So 80 divided by 5 is going to give us 16 radian per second square. So option B is the right answer. Right? So just make a note of it. Just give me a minute, guys. So after this, yes, once you finish this, you people try the sixth one. Shall we move on to the next one? So how to do the sixth one, guys? So question says there is a homogeneous solid cylinder roller of radius capital R and mass M, which is pulled on a cricket pitch by a horizontal force F. Assuming rolling without slipping, angular acceleration of the cylinder will be. It's very simple. So in the question, the one that is missing is capital F. Here capital F is there, no? They have not given it in the question, but when they say horizontal force, it is capital F.
Sir, how do we know which axis we are supposed to take, sir?
How do you know?
Which axis we are supposed to take for the moment of inertia?
See, the only thing is, if a cylinder has to roll, okay, since this is a solid cylinder, okay, they have mentioned it. See, I'm going with the logic only because this question is actually ambiguous. You raised the right question. This question is ambiguous because they didn't tell where the force is applied. Okay, whether they didn't tell me whether it is applied at the bottom or at the top. So they are saying a homogeneous solid cylinder of radius R and mass M is pulled on a cricket pitch. Okay, so if it has to be pulled, I am assuming that the force is applied here. Logically, they are going to apply it there only, right? So have you seen those rollers and all, how they are? They're actually be hinged at the center also sometimes. So what you can do is it will be like a trolley. They can pull it like this also. So nothing is mentioned. But here, since it is horizontal force, I'm assuming that the horizontal force can be applied only at the topmost portion. Varun, are you able to understand what I'm trying to say?
Yes, sir.
Right? So I've taken it like this, assuming rolling friction without slipping, angular acceleration of the cylinder. Here, one more data which is ambiguous is, I don't know what is capital F. That is not there. So I have assumed it to be capital F. Let's try the problem. Let's see if we are able to get the answer. And one more information is also missing, whether the floor is having friction or not. That is also not there. Because see, I thought the problem is like it's like the previous one. Torque is equal to I alpha. If I apply, what is that I'm supposed to get? Torque is equal to I alpha. Let's assume. So in this case, Varun, answer me. The cylinder is rolling about which axis?
About
Are
it
you able to?
ends.
Are you able to? So, no. It is not rotating about the end. Okay. I hope you didn't get the idea. I'll show it to you. Wait. Guys, those who are not able to visualize, look at this. Just a minute.
Sorry, sir, it's about its center only.
It is about?
It's center only.
Yeah, it is going to rotate about center. See, for example, if this is the cylinder, okay. Let's assume this is the cylinder. You are able to see only this tube. Okay. This is the cricket pitch. This is the cricket pitch. So there is a horizontal force. What I'm trying to say is sometimes what will happen, the cylinder will have this much thickness, right? So what they can do is they can have a handle here and they can pull it also. Or they can have it at the center and pull it. Okay. Had it been hinged at the center and if they were pulling it, what would have happened logically? Had they had it at the center and they are going to pull it, let's say the force is like this, then what would have happened to it? What would have happened to the cylinder? Think logically.
Sir, it wouldn't have rotated, it would have just gone forward.
Okay. It would have gone forward in the sense, what kind of motion are you trying to propose? So you're saying there is no rotational motion, only translatory motion, right?
Yes, sir.
Okay. But I have another question. If it was only this force which was responsible to the cause of motion of this object, yes, what you're saying is right. It would have only been translatory motion. Even in this scenario, had it been the case where it is rolling, I'm repeating it, had it been the scenario where here still it is rolling, then what other force should have existed? If this has to roll, okay, if any object in a circular motion, generally these rollers and all those things, if they have to roll on a surface, then what is the other force that is necessary?
Friction.
See, I'm trying to put all these points. Nothing is clear in the question. It is just my perspective I'm trying to ask.
Sir, is it friction?
It should be friction, right? So the friction, had it acted in this direction, then the friction would have caused a rotation motion like this. Are you able to understand, guys? So this friction would have actually pulled it like this, and it would have rolled. So friction will be in this direction. The rolling would have taken place in this direction. Am I clear with that perspective? Okay. So here, to be honest, even I don't know what is the question. I don't know where the force is applied. I am assuming that it is applied at the top, and I'm going to start solving the problem. Okay. I'll tell you why I started thinking like this, because none of the options which were there in my mind were matching. Had we did this problem similar to the previous one, had we done it like the previous problem, let's see what would have happened. So torque is equal to I alpha. That's the logic we have. Right? I'm assuming the previous problem, nothing was mentioned about friction, so I took it into consideration and I started solving it. Right? Just a minute. So nothing was mentioned about friction, so I solved it. But here, if I do the same logic, what would have happened is F into R should have been, what should have been the answer? Since they told a solid cylinder, what is the moment of inertia of a solid cylinder? Sorry?
mr square by 2.
It should have been mr square divided by 2 into alpha. R and R would have got cancelled. Alpha should be 2f divided by m into r. If you observe, none of the options were matching. Okay, don't worry about this question. This is actually ambiguous. They should actually give you marks if this comes in your exam, because one data F is missing and the other data friction is missing. You will definitely get marks. But let's try to understand this problem. Okay. So since this is not matching, since the answer which I'm getting is not matching, what should have happened? Had this 3 maybe not there in this, then my answer would have been right. Right. So what we will try to do is we will try to solve this problem by taking friction into consideration, and then we'll proceed. Okay. Let's assume. Okay. So if I need to take the friction into consideration and start solving, what I will do is I will take this horizontal force to be at the center, because that is how a roller is designed. Right. Just to explain you, I will share an image. Wait. One minute, guys. Just a minute. See, this is the one I'm trying to talk about. Are you guys able to understand? So this force, where should it come from? Will it come from the tangential part or from the center? So since they have mentioned it as a solid cylindrical roller, this is how it is going to be. So this part is there, no? This handle is actually going to be horizontal and there will be a frictional force acting here. So in this context, who is responsible for the rotational motion of the object? Is it the horizontal force or the frictional force? So as we discussed, it is the frictional force. Now tell me, guys. So acceleration will be in this direction, angular acceleration will be in this direction. So this approach is wrong. So what am I supposed to do? Tell me how to frame the equations. So here we are going to frame the equations for two cases. One is translatory motion and the second is for rotation motion. So who can tell me the equation for translatory motion? It is capital F minus small f is equal to, guys, are you there? Are you able to understand what I'm trying to say?
Yes, sir.
So capital F minus F is equal to what?
MS.
MA.
MA. So M into A. Similarly, how to frame the equation for rotation motion, that is torque?
Torque equal to I alpha.
So how to frame the equation for rotation motion? It's simple, guys. Who is responsible for rotation motion? It is friction. So small f into capital R is equal to what?
I alpha.
I. That's what we need. So, A equal to R alpha. So alpha will equal to by R, which implies F into R is equal to I into A divided by R. So for small a, then I will find alpha from that. Okay. So F will be equal to, or I will leave it like this only. F is equal to, let me leave it as I alpha only. So F is equal to I alpha divided by R. So how to solve this? Capital F is equal to small f plus MA. So it is I into alpha divided by R plus M into A. So in the place of A, can I write it as R alpha? So I is MR square by 2 into alpha divided by R plus capital M into R alpha. Guys, tell me what is going to be the answer.
Sir, it's 2F by 3 MR.
That's right. So alpha will be equal to 2F by 3 into M into R. I hope everyone got this answer. And you're clear with the concept also. Is there anyone having a doubt?
Yes.
So if at all in the future you face this kind of a question, If you see it as a cylindrical roller, then the horizontal force is applied. Okay, because they mentioned the scenario where it is being used. So in a real-time application, the force has to be applied only at the center. So alpha is equal to 2F divided by 3 into M into R. Right? So, but I hope you guys are able to understand that it is still rotating about its center of mass. Right? It's still rotating about its center to find out what is the axis of rotation. Varun, clear?
Yes, sir.
Bharat? Are you clear?
Sir, I need to watch the other videos of this topic.
Okay,
so-
that's fine. But now you are able to understand, right? I understand.
Yeah.
So keeping the formula part aside, are you able to understand the concept?
Yes, sir. Yes, sir.
That's fine. Okay. So shall we move on to the next concept then? So
Yes,
this is
sir.
all about pure rolling. So now we will do some problems which are based on collision and rotational motion. Okay. So let's see. So when we speak about collision and translational motion, what all come to our mind? What are all the factors that come to our mind? When we speak about collision, what are all the physical quantities that are conserved?
Momentum, linear momentum and kinetic energy.
Okay. Yes. Depending on which of the physical quantities is conserved, basically collisions are classified into two types. What are they? Elastic and inelastic. So what can you say about the elastic collision? So what are all the physical quantities that are conserved? Linear momentum and kinetic energy. If these two physical quantities are conserved, then we call the collision as elastic. If only linear momentum is conserved, we call it as inelastic. I hope you're able to understand. So what is the common factor in both? Whether it is going to be an elastic or an inelastic one, the linear momentum is always conserved. This is about collisions in which kind of a motion? Translatory motion. So when a question is given, how will you identify whether it is a translatory or a rotational one? Translatory is caused by force. Rotation is caused by torque. Right? So in a similar concept, we are going to see collisions in rotational motion. This is not a separate concept. It is just an extended concept from translatory one. So it is not a separate thing. The only condition we are going to apply is what changes will take place, guys? What is the only change that is going to take place? It is all about angular momentum, because when we deal with linear momentum, we need the quantities like mass and linear velocity. Whereas when you talk about rotation motion, instead of mass, you need the moment of inertia. Instead of linear velocity, you need the angular velocity. So the product of both is going to give us angular momentum. So indirectly, if you see, this is based on conservation of angular momentum, except the fact that the objects are going to come in contact. Okay. So let's try out a few problems. So if there is any doubt about the axis of rotations, please ask. So there are two coaxial disks, means they share the same axis of rotation. Having moments of inertia I1 and I1 by 2 are rotating with respective angular velocities omega1 and omega1 by 2 about their common axis. So this is the information that is given. Okay. So with this information, wherever you have moment of inertia and angular velocity in your hand, okay, if you have the data about moment of inertia and angular velocity, what are all the physical quantities which are indirectly known to us?
Kinetic energy and angular momentum.
Yes, you know the rotational kinetic energy and the angular momentum. So rotational kinetic energy in the case is half I omega square and angular momentum is I omega. So you know both these quantities for both the objects. They are brought in contact. So which is nothing like collision only. with each other, and thereafter they rotate with common angular velocity. So it is like what type of a collision?
Inelastic.
It's a perfectly inelastic, because in inelastic also you have the coefficient of restitution to be less than 1 and coefficient of restitution to be 0. I hope you remember these things. So when will you say the coefficient of restitution is 0, guys? That is when two objects are moving with individual velocities u1 and u2. They can be in any random direction they want. After collision, if they start moving as a single object, means if they attain a common velocity v, we call it as a perfectly inelastic collision. Right? So it's a perfectly inelastic one. If EF and EI are the final and the initial total energies, then EF minus EI is how much? So since it's a since it's a part of inelastic collision, there is a definite understanding that loss of energy is going to take place. EF minus EI, is it going to be positive or a negative one?
Negative.
So it's a negative one, right? So option, according to me, should have been only the first one or second one. Let's try to solve and see. Now, how else can I proceed? So this is all the information that is given, and they are expecting us to find something. So how do we proceed, guys? You tell me, no? So,
Sir.
see, yeah, tell me.
So we can find the final angular velocity using conservation of angular momentum.
Okay, let's use that. Conservation of angular momentum. So, according to conservation of angular momentum, I can say I1 into omega 1 plus I1 by 2 into omega 1 by 2 is equal to, what is the final angular momentum? I1 plus I1 by 2 into omega dash, because it is attaining a common velocity. Let me call it as omega dash. So what is the value of omega dash, guys? It is, what will be on the left hand side? So it will be 5 I1 omega 1 by 4, and left hand side will be 3 I1 by 2 into omega dash. So I1 and I1, here 2 will get cancelled, which implies omega dash is equal to 5 omega 1 by 6. This is the common velocity attained. Okay. But their interest is not about finding the common velocity. Their interest is to find out the loss in energy. So, what is the initial energy that is possessed by the object? They told total energies, means since the object is only revolving, what kind of energy can be defined for it? Can be defined kinetic energy, potential energy, or both? In this context, here then they say EI as the total energy. It is the kinetic energy of the first object plus the kinetic energy of the second object. Because for potential energy to be defined, we need to know certain configurations. So here we don't take it into consideration. So when they say an object is revolving, we take only the kinetic energies into consideration, right? So kinetic energy is half I1 omega 1 square plus half I1 into omega 1 by 2 the whole square. So what will be the answer, guys? Solve and tell me. Similarly, E final is equal to half into I1 into omega dash square plus half into I1 by 2 into omega dash square. So substitute and tell me what is the answer. Make it fast. What is the value of EI, guys?
5 I1 omega 1 square by 8.
5 I1 omega 1 square by 8. Okay. What about E2? That is E final. This is 5 I1 by
No problem at all.
dash. It is 5 omega 1 by 6.
Sir,
Yeah, tell me. Any mistake?
in the EI equation, the second kinetic energy,
Yeah.
it should be half I1 by 2, right?
Oh, sorry, I missed it. I'm sorry. Yeah, half I1 by 2. Then what will be the answer? It will be 16 in the denominator, right?
9 I1 omega 1 square by 16.
Okay, 9 I1 omega 1 square by 16. Okay. So here what is the answer? 5 I1 into 25 omega 1 square divided by 4 into 36 is 144. So it is going to be 125 I1 omega square divided by 144. So E final minus E initial is 121 I1 omega square, 125 I1 omega square divided by 144 minus 9 I1 omega square divided by 16. So LCM is how much? 9. So 125 minus 81 is how much? But how am I
44.
getting? But how am I getting a positive value? That's not possible. Wait, is there any mistake? No, it's not possible. We can't get. So are they asking EA minus EF, EF minus EA only? No. EF minus EA has to be a negative value. Okay, wait.
Sir, 3I by 4.
Yeah, that's a mistake I made. So it is 3I1 by 4. So 3I1 means here it is 144 is common, right? So here it will be 3. Yeah, it is 75. Yes, this is the difference. So it will be 75. It should be less. So it is 75. So 75 minus 81 is minus 9 I1 square, I1 omega 1 square divided by 144. It will be minus I1 omega 1 square divided by 75 minus 81. So it is almost 6, sir. Yes, minus 6 divided by 144. So I1 omega 1 square divided by 24. Is there an option like this? Yeah. So minus I1 omega 1 square divided by 24. Guys, are you able to understand the concept? Right?
Yes, sir.
Right. So let's see the next problem. Shall I move on?
Sir, what was the reason that you said for the final energy to be less than the initial energy?
See, the reason is very simple. It is because what type of a collision did I say? It is inelastic. In inelastic collision, kinetic energy is not conserved. We have to understand. See, I'm not written kinetic energy, right? So when I say kinetic energy is not conserved, only thing that could have happened is the final energy should have increased or decreased. Remember, in this world, nothing is going to increase without you giving any input. Here, so the energy is the only possibility for the energy to happen here is it has to decrease because they are coming in contact and friction is going to decrease the velocity, the common velocity of the object. So the energy is lost in the form of heat. Are you able to understand? So,
Yes, sir.
okay. One thing, it will be lost in the form of heat and sound also. So that's why I could confidently say you will get a negative value. Okay, second one. Guys, you can try the next one. So this is also a good problem. So consider an object shown in the figure consisting of two identical balls, each of mass capital M, connected by a light rigid rod. So when they say light, the mass is 0. If an impulse of J is equal to M into V is imparted to the body at one of its ends, what could be its angular velocity? So how to proceed? So here you have to be very careful. What have they told? They have mentioned about impulse, right? So impulse is given as mass into velocity. Recollect from the laws of motion chapter, how is impulse related to momentum?
Impulse is equal to rate of change of linear momentum.
You're making the same mistake again.
Change in momentum.
Yes. So change in momentum, see, observe, I'm repeating it again, don't get confused. Change in momentum. If there is a word rate of, then it means force. That is Newton's second law. If it is only change in momentum, it is impulse. And for your understanding, they have clearly mentioned M into V, which is nothing but momentum only. So there is a momentum which is applied. So there is an impulse that is applied at one of the ends. By doing so, what will happen to the system of these two masses connected with the help of a light string? So the linear momentum is taking up the responsibility of putting the system into translatory motion or rotation motion. You're not able to visualize it? Wait. See, just a minute. This is the rigid rod, light rigid rod. There are two masses which are kept at the ends. Okay, one mass here and the other mass here. There is an object which is traveling towards one of the ends and it is imparting an impulse like this. Observe what is going to happen when my finger strikes this with certain impulse. Okay. Observe what is happening. What is happening? So once this strikes, this light rigid rod will be put into rotation like this. It is one thing to be clear here is it is not going to revolve about a fixed axis because they didn't mention anything about the axis. But what is going to happen to it? When this is going and hitting here, maybe if the ball that is creating the impulse had it hit at the center, then it would have had only a translatory motion. It would have traveled like this. But they created the impulse at this end. So what is happening to it? It starts revolving, that is rotating, right? That is the reason why in the question they have clearly asked about what parameter are they asking us to find?
Angular velocity.
Angular velocity. So the angular velocity for this symmetrical system, why I am able to say it is symmetrical system is because the masses which are connected at both the ends are equal and the string doesn't have any mass. So it's a symmetrical system. Once it starts revolving, what is going to be the angular velocity of this system at the center? That's the question. And we also know that for a rigid object, the angular velocity of every particle is going to be the same except the linear velocity, right? So if I'm able to calculate the angular velocity of the center of mass, my answer is, my problem is solved, right? So how do I approach? That is a question. How do I approach it? Because here they didn't give us any direct information. It's all indirect. One thing I've always been telling you: if an object has to revolve, what is necessary?
Torque.
Torque. So where is the torque being exerted? Who is exerting the torque on this object? There is some external source. What is the external source according to the question? You can look at the WhatsApp.
The impulse.
The impulse, right? So that is creating the impulse. Now the question is, how do I relate that impulse to torque? Impulse is change in momentum, right? So if I talk about translation, the impulse which is causing the translational motion, rate, it is the rate of linear momentum. If I'm talking about rotation motion, it is the rate of change of angular momentum. Correct? Am I right? Are you guys able to understand this point? Is there any doubt?
No, sir.
No, right? Shall I proceed?
Yes, sir.
Listen. Yeah. So if there is anything that is confusing you, please let me know. Okay, now let's think. Now, how do I frame equation, guys? How do I frame equation? I have the only information that I have in my hand is about this impulse. That too, it is given in terms of linear momentum. So, from impulse, if I want angular momentum, how do I write? So, for that, we need to revisit the definition of angular momentum. Don't tell me the mathematical formula. Tell me what is the definition of angular momentum.
Moment of linear momentum.
So, moment of linear momentum, right? So, wherever the word moment comes, what did I say?
The axis of rotation, like the distance from the axis of rotation into the linear value.
Very good. So the linear momentum should be multiplied. Moment means it is rotation. So the linear momentum should be multiplied with what? With the distance to the point where this linear momentum is acting from the axis of rotation. So here, as I told you, the object is going to revolve about its center. What is the distance from the center to the other end? I hope you guys are convinced why I told center, because it's a symmetric system. L by 2. Now tell me what is going to be the angular momentum caused due to the impulse.
MV L by 2.
So it is J into L by 2, that is equal to, this quantity should be mathematically equal to what? See, like how I said torque is equal to I alpha, where torque left hand side I write force into R, force into distance from the axis of rotation. Here how should I write? Angular momentum will be equal to I into omega. Are you convinced with this equation? This is the answer, that's it. With this only you are going to get the answer, but I have explained the whole context. Shall I proceed? So mv into L by 2, right? mv into L by 2 is equal to, what is the value of I?
ml square by 4.
ml square by
4 or 3.
You're talking about a rigid rod, ml square by 3.
Yeah, yes. Oh, light rigid.
Yes, I thought you would make this mistake. Yes, because it's a light rigid rod. So here the moment of inertia is contributed only by the masses at the end. So m into L square by 4 plus m into L square by 4. I hope you understood why it is L square by 4. Because if I take this as a point mass, the moment of inertia of a point mass from the axis of rotation is m into r square. Here r is L by 2 the whole square. That's why I wrote ml square by 4. So ml square by 4 is the moment of inertia of each ball into omega. Right? So all the m's are same, right? Yes. So these m's will get, yeah, tell me.
Sir, I didn't understand how you wrote the inertia part.
See, inertia part, what I'm trying to say is, here, see, two balls and a rod, right? So moment of inertia, is it a scalar or a vector quantity?
Scalar.
It's a scalar. So scalar means I can add the moment of inertia of all the objects that are there. So this system consists of three objects. Two balls, which are particles. Okay, they didn't say it is a sphere. When they say two identical balls, I took it as a particle. Had it been a sphere, things would have been different again. Okay, you should have applied parallel axis theorem. Here I'm taking it as a particle, m, and this rod doesn't have any mass, right? So what is the moment of inertia of the first particle about this axis O? M into L by 2 the whole square. Right? That's why I wrote ml square. Got it?
Yes, sir. Yeah, got it.
Yeah. So V into L by 2 is equal to L square by 2 into omega. L and L will get cancelled, 2 and 2 will get cancelled. Omega will be equal to V divided by L. Is there an option like that? First one. If you observe, this problem is directly telling us like V is equal to R omega. But you cannot take it directly, okay? You have to apply all these concepts, because had the impulse value been different, your answer would have changed. Guys, am I clear with the concept?
Yes, sir. Yes, sir.
Make a note of it. Okay. Shall I proceed?
Yes, sir.
Yeah. Let's look at the third one. It's a 2 mark 1999 question. See, sometimes if your luck is good, the questions will get repeated. A smooth sphere A is moving on a frictionless horizontal plane with an angular velocity omega and the center of mass velocity v. It collides elastically and head-on with an identical sphere B at rest. Neglect friction everywhere. After the collision, their angular speeds omega and omega b will be how much? See, I'll ask you a scenario, okay? There is an object of mass m which is moving with initial velocity u, is undergoing a head-on collision with an object which is at rest. Okay, after collision, what will happen?
Sir, both masses move together with u speed.
That will happen when it is an inelastic collision.
Oh, elastic.
It is an elastic head-on and elastic
Sir,
and head-on. Yeah,
U by 2.
No. It's not like, see, it is not like they will get divided exactly, because Varun, you will get the answer as u by 2 when you write mu plus m into 0 is equal to m plus m into b. Then it will be u by 2. But I can write this kind of an equation only when they have a common velocity. What you're again thinking is inelastic, perfectly inelastic collision, which is again wrong. Yeah, tell me, Harini, you were about to say something.
The second object will move with a greater velocity than the first one.
Nothing will happen. Where will it get the greater velocity? Nothing will happen. It's a very simple concept. First will come to rest and the second will start moving. How I am saying is, you can again do it as a homework. There is a big formula like this. V1 is equal to M1 minus M2 divided by M1 plus M2 into U1 plus 2M2 divided by M1 plus M2 into U2. If you don't remember, right? You know this formula, right? Guys, do you know this or not?
Yes, sir.
Yeah.
Yes.
So you have this big formula, right? If M1 is equal to M2, substitute and see what will happen. V1 is the final velocity of the first object. This is the first object. This is the formula for the elastic collision one. If M1 is equal to M2, the first term would have been 0. What about the second term? In this scenario, U2 is 0. Second term is also 0. So what can we say? The first object will come to rest. Whereas, since in a perfectly elastic collision, energy is conserved, the remaining energy is transferred to the second object. So, the second object will start moving with the initial velocity of the first object. The similar context is applicable here also. Tell me the answer. It's just one step. Is there going to be a decrease in the velocity of the first object? Is the first option right or wrong? Sorry?
It's right, sir.
So how are you saying it is right? Omega is less than omega b because it has become 0 and like that? Are you thinking in those terms? Okay.
Yes, sir.
If you're thinking those, if you're trying to say this is 0 and this is a non-zero value, that is why you're saying omega is less than omega b. Okay, I'm accepting it. But let's look at which is more precise answer. Omega is A is equal to omega b. Obviously, no. Omega A is equal to omega means the first object is still going to continue to move. Answer is no. Omega b is equal to omega means the second object has acquired the initial velocity of the first object. Is that right or wrong?
It's right, sir.
It's right. So out of, in comparison to A and D, which is more precise?
Option D.
That's the answer. Okay. So are you able to understand how to connect the dots? That's why I told you this chapter is important. You need to have a grip of the previous chapters also.
Sir, is this the case for all elastic collisions?
Which one? You're talking about the...
First object comes to rest and...
No. That is going to happen only if both the masses are same. Two important conditions to be satisfied for this kind of a scenario. This is a special case actually. Okay. If both the masses are same and the second object is at rest, this will happen. The reason for it is...
For both type of collisions?
No, only for elastic.
Okay.
So it should be elastic. So make a note of all these points. It should be elastic head-on collision, means it's a one-dimensional collision. So for an elastic one-dimensional collision, if both the masses that are undergoing collision are the same and the second object is at rest, then this kind of a scenario will take place. Or else, you should apply this big formula and then solve any problem. Had the masses been different, velocities been different, then we need to go with this formula. So this formula V1 is equal to M1 minus M2 by M1 plus M2 into U1. All these things is applicable only for one dimension. It is not applicable for oblique. Okay. I hope you're able to understand.
Yes, sir.
Okay. So you can go through it. If you have any doubts, you can let me know. So let's move on to the fourth.
Show that big formula.
Yeah. Done?
Sir, 1 minute. Almost.
Yeah, make it.
Done, sir.
Okay. So let's do the next one, guys. So this is also an important concept again. This is called as toppling concept. Toppling. Okay. Again, you people are going to explain what are the physics behind this. So there is a cubical block of side A, which is moving with a velocity v on a horizontal smooth plane. So there is obviously no friction. It hits a ridge at point A. Means there is a small, let's say, a small obstacle here. Okay, at point O. The angular speed of the block after it hits O. So you read the question carefully. What did they say? Is moving with a velocity v. Now the question is it having translatory motion or rotational motion? The answer is very clear. It is only having translatory motion. But if you see the question, they are asking what is the angular speed? Where will that angular speed to this object come from? Why is it going to attain angular speed? Let's think about it. Why is it happening? Who can explain this? It's a simple logic. See, nothing much to think about it. Let's say you're walking, okay? You're looking straight and walking. Let's say I keep a small obstacle here. You're walking towards it. Once you hit this, once your foot hits this obstacle, what will happen? Will you still be able to move in the same straight line path? Let's say you have not seen the obstacle. What would have happened to you? You will fall like this,
down.
right? So you're not going to fall in the perpendicular way. Rather, you're going to fall in a parabolic way. Accept it. Right? That's what is going to happen because you're not able to balance this. Whatever momentum you had, it has undergone a collision with some object. Since you're not able to balance it, you're going to topple. This is what is called as toppling. So you're going to topple and fall. So you will start rotating about this axis. Right? You're going to start rotating about which axis? The axis which is to the floor. The same thing is going to happen to the block also. The block will start revolving. So when I say the block is going to revolve, it is going to revolve about which axis? So can I say the scenario will be like this when the block has hit the obstacle, it will be like this. This is the point, right? So if I take the center of mass to be P, it is going to have an angular velocity omega like this. Guys, am I clear with this? Our work is to find what is the value of omega. How do I proceed? So here we need to answer certain questions. So is this an example of collision? The answer is yes. Right. Now I have another question. Here, the object which had translatory motion, all of a sudden got converted to a rotation motion. Why is it happening? Because of the collision. Now, when the collision is taking place, I'm trying to find out what is the torque acting about point O. Can someone tell me what is the torque acting about point O? What is the torque acting about point O, guys? Answer is very simple. It is zero. There is no torque about it. But when the torque acting about the axis of rotation is going to be zero, okay, here I'll ask you another question. Is it a natural axis of rotation or instantaneous axis of rotation?
Instantaneous.
It is instantaneous, right? So when that is happening, observe, when a torque about an axis of rotation is 0, can I conclude that the angular momentum is conserved? Why? We know that force is equal to dp by dt. If I ask you to state conservation of linear momentum, what will you say?
The external force acting on the system is
Yes.
0.
When the external force acting on the system is 0, linear momentum is said to be conserved. In a similar context, if angular momentum has to be conserved, then the torque has to be 0. Since in this case, the torque is going to be 0. Okay. Now, what is the angular momentum which was there initially, and what is the angular momentum that is there finally? So just before collision, the block would have been like this. It had a linear momentum in this way, right? So what is the angular momentum of this object about point O before and point O after? Guys, is there anything that is confusing you? You're not able to understand any point. You want me to explain? Is there any point that is unclear? Or are you not able to visualize what is happening? Okay. So I hope you're able to understand, right? So what is the initial angular momentum? Can someone tell me? Angular momentum. Sorry? It is not 0. See, it is 0 only if it is going to be at rest. It is having a motion. It is having a linear momentum. So, whereas you're trying to define, see, whenever you're defining angular momentum, you need to define about an axis, right? Here, what is the axis we are trying to define? About point O. What is the angular momentum of the object about point O before collision? It is something similar to the second problem. Its momentum is there at the center. And there is a distance between the center and the axis of rotation that we have considered. How much is that distance, guys?
A by 2.
A by? Now, what is the initial angular momentum? It is mv into A by 2. Accepted?
Sir, but then it does not possess any rotational motion, right?
No, it need not be. It need not possess any rotational motion. It is having an angular momentum, right? The same is the scenario with the second one also. Right? So what is the basic definition of angular momentum? It is the moment of the linear momentum. That's it. Okay. So what I'm trying to say is it is because of this linear momentum, it has the tendency of rotating with an angular momentum of this much value.
Okay, sir.
Okay. That should be equal to, what is the final angular momentum? So initially the angular momentum was contributed due to the translatory motion. Listen to it carefully, guys. Why I'm saying translatory motion is because it had linear momentum. Linear momentum is translatory. So initially, when you're framing the equation, you need to take the linear momentum into consideration. But after collision, the object is being set into pure rotational condition, accepted. So when it comes to pure rotational condition, it is possessed by the moment of inertia. Moment of inertia multiplied with the angular velocity omega. So in this question, the challenging part is to find out what is the moment of inertia about point O. How do I find it? Is there anyone having a doubt with the equation that I framed?
Yes, sir.
Clear? Okay. So MV into A by 2 is equal to, what is the value of I naught, guys? can I say I naught is equal to, I'm going to apply parallel axis theorem. Can I write it as moment of inertia about the center of mass plus the total mass of the object into OP square into omega. So I applied parallel axis theorem. So what is the distance between O and P? What is the distance between O and P, guys?
A by root 2.
Very good. Had you told A by 2, that would have been wrong. It is A by root 2. Means it's a three-dimensional shape. Understand, okay? It is from one of the corners. Okay? From one of the corners to the center. It is going to be A by root 2. So what is the moment of inertia of a cube about its center of mass? It is, make a note of it, it is ma square by 6. Okay? Plus m into, what is the distance between O and P? It is a by root 2. So a by root 2 the whole square, the whole multiplied with omega. M into V into a divided by 2. M will get cancelled. V and a also will get cancelled. Okay, I'll not cancel a by 8. V into a by 2 is equal to a square by 6 plus a square by 2 into omega. A will get cancelled. 2 will get cancelled. So V is equal to a by 3 plus a, that is 4a by 3 into omega, which implies omega is equal to 3v by 4a. So understand here, is there an option on it? 3v by 4a, yes, first option. So the problem which is given here is a concept. So this was asked in 99. In today's exam, there is a concept. Okay, so try to understand this and try to learn it like a concept. So what are all the important points that you need to know? The object which had translatory motion, when it met an obstacle, it has got converted to pure rotation motion. Okay. Similarly, the torque about the point where it is undergoing the collision is going to be 0, and there is conservation of angular momentum that is taking place, and we have framed the equations. Clear, guys? Shall I move on?
Yes, sir.
So 3v by 4. Okay. Okay. Just to ensure that you have understood this concept, let's try the sixth one. In the fifth and the sixth one, understand that more than one option can be right. Yeah, let's do the sixth one. So there is a uniform bar, means it has mass of length 6a and mass 8m, lies on a smooth horizontal table. 2 point masses m and 2m moving the same horizontal plane with speed 2v and v respectively strike the bar as shown in the figure and stick to the bar after collision, denoting angular velocity about the center of mass, total energy and center of mass velocity. Okay, they're denoting it by, they're denoting the angular velocity, total energy and center of mass by omega, E and Vc respectively. What are these values after collision is what they're asking. So let's try to understand this, okay? This question is again similar to which problem that we did today. It's similar to the second problem, right? Yeah. Now, the only difference between the second problem and this one is, in the second problem, they use the word impulse. Here, what are they using? They have given you the mass and the velocity. So when mass and velocity is given, it is easy for us to define the linear momentum, right? Indirectly, linear momentum is known and its kinetic energy is also known. Now let's try to answer certain questions from the information that we have in our hand. So first question I have in my mind is, what type of a collision is taking place? What type of a collision is taking place? They told one important word. They stick to the bar after collision. So what does it mean?
Elastic.
Perfectly inelastic collision.
It is perfectly inelastic. Huh? They stick to the bar, no. It is perfectly inelastic collision. So whether it is elastic or perfectly inelastic, angular momentum is conserved, right? So let's try to frame the equations for angular momentum. So here you're trying to define the angular momentum about which point? About? Tell me. So you're trying to write the angular momentum about which point? They've told no, about the center of mass. So you're trying to write the angular momentum about point C. So first, second. Okay. So what is the angular momentum caused due to the first object? See, whenever you're defining angular momentum, no, there are certain points which you need to have in your mind. Because of this mass 2m, is the object going to revolve in clockwise or anti-clockwise direction?
Anti-clockwise.
Anti-clockwise. Similarly, due to mass m,
Anti-clockwise.
anti-clockwise. So what is the important point in this case is the angular momentum due to both these masses will get added. Correct? So what is the angular momentum about point C? It is 2mv due to whom? Due to the first object, 2m into v into what is this perpendicular distance? They have given it. It is a plus. So this is initial. So 2mv into a plus 2mv into, due to the second mass, what is this distance? That also they have given into 2a is equal to L final. So generally what will happen is, here again the translation motion is being converted to rotational. So whenever rotational comes, we need to involve moment of inertia. The moment of inertia about point C into omega. Accepted? So it is 5 MVA, that is equal to, what is the moment of inertia about point C for this rod? You need to be careful here because it's a uniform bar. So what is the moment of inertia of a rod about its center of mass? ml square divided by 12, right? So here the mass is 8m. 8m into length is 6a. 6a square divided by 12 plus. What to see? One more point to be kept in our mind. These two particles are getting stuck here. So when they are getting stuck at this point, They are like particle masses acting at a certain distance from the axis of rotation. So what will be the contribution of their moment of inertia? 2m due to the first object into, what is the distance, guys?
A square.
Very good. Plus m into
2A the whole square.
that is 4a square. This whole thing multiplied with omega. If you calculate this, you will get the answer. So m is obviously going to get cancelled. 1a is gone. So 5v is equal to, this will go 2 times, this will go 4 times. 4a plus 2a plus 4a into omega. So what will be the value of omega? 5v divided by v divided by 2a. Is there an option like this?
Sir, LHS is having 6V, sir.
Sorry. 6. Now is it fine? So if LHS is 6, then I should get 3 by 5. That is option B. So 6, that is 3v by 5a. Correct? So 3v by 5. Am I right, guys? So since here more than one option is right, can I say VC is equal to 0? Can I say VC is equal to 0 or not? So what is VC? That is the translational velocity of the center of mass. Now let's answer one question. Is this system being set into pure translational motion or pure rotational motion or a combined translational and rotational motion?
Pure rotational motion.
Pure rotation, right? So what can I say about VC?
0.
It is 0, right? So VC is 0. What else can we say? What else is there? So what can you say about the energy? So E is equal to, they have given 3 by 5 mr square. Since you know the velocity, what you can do is calculate half I omega square. That will give you the final velocity. And put V is equal to R omega. You will get the answer. Okay, that part I'm leaving it to you. Once you substitute all these values, check whether you are still getting it as 3 by 5 mv square. If that is the case, then your answer is right. Okay, so keeping all those things, the calculation parts aside, did you understand the concept? If you face this kind, if you get this kind of a problem, will you be able to solve?
Yes, sir.
Yes, sir.
Yes, that's good. So time is 8:27. Okay, then we'll wind up. Just give me a minute. Don't leave.